Imagining a flat Earth, look up at the night sky. It's a tapestry of stars, a vast dome peppered with points of light. For centuries, humans have gazed upon this canvas and pondered our place in the cosmos. Some ancient cultures believed the Earth was flat, a stationary platform at the center of the universe. This idea might seem absurd today, but what if it were true? What if our planet wasn't a sphere but a flat disk? Imagine a world where you could fall off the edge, a world with no curved horizon, where the sun and moon hovered above, illuminating the disk like cosmic spotlights. It's a strange and fascinating thought experiment, one that challenges our understanding of the universe and our place within it. The flat Earth model, as you might have guessed, proposes that the Earth is not a sphere but a flat, disc-shaped plane. This disk is often depicted with the North Pole at the center and a massive ice wall, Antarctica, encircling the perimeter, holding back the oceans. The sun and moon are much smaller and closer than in the scientifically accepted model, circling above the Earth like celestial lamps. Gravity in this model is often either denied or explained as a downward force pushing everything toward the flat Earth's surface. While this model might seem appealing in its simplicity, it quickly unravels when confronted with scientific evidence. The very laws of physics that govern our universe contradict the possibility of a flat Earth. The idea of a flat Earth wasn't always considered outlandish. Many ancient cultures held this belief. The Babylonians, for instance, envisioned the Earth as a flat disk surrounded by a circular river. Similarly, ancient Egyptians saw their world as a flat plain with the sky arched overhead. These beliefs were often intertwined with mythology and lacked the benefit of scientific observation. The shift towards understanding Earth as a sphere came gradually. Greek philosophers like Pythagoras and Aristotle, through observations of lunar eclipses and the changing positions of stars, began to deduce Earth's spherical nature. It was the voyages of exploration, like those of Ferdinand Magellan's fleet, that cemented this knowledge. By circumnavigating the globe, these explorers provided irrefutable proof of our planet's spherical shape. The flat Earth model might seem charmingly simple, but it crumbles under the weight of scientific scrutiny. Let's start with gravity. On a spherical Earth, gravity pulls everything towards the center, explaining why objects fall down and why we stick to the ground. On a flat Earth, gravity's pull would be inconsistent. Objects closer to the edge would be pulled sideways, while those at the center would experience a more familiar downward pull. Then there's the issue of celestial observations. The phases of the moon, the seasons, and the varying lengths of day and night can all be explained by Earth's rotation and orbit around the sun. These phenomena become inexplicable on a flat Earth. And what about the countless images of Earth taken from space, clearly showing a spherical planet? Flat Earthers often dismiss these as elaborate fakes, but to accept that, one would have to disregard the overwhelming consensus of the scientific community. Section 5. Lost in space navigation and exploration on a disc-shaped world. Imagine a world where compasses pointed not north, but towards the center of the disk, where circumnavigating the globe meant traveling in a giant circle around the North Pole. This is the reality of navigation on a flat Earth. Long-distance air travel, reliant on understanding Earth's curvature, would be impossible. Satellites orbiting a sphere wouldn't exist, disrupting communication systems and GPS technology. Exploration, too, would be fundamentally different. Reaching the edge of a flat Earth would be the ultimate adventure, though a potentially perilous one. Would explorers fall off, or would they encounter an impenetrable barrier? The very nature of exploration, of pushing the boundaries of the known world, takes on a whole new meaning when the world is a finite disk. Section 6. The Flat Earth Conspiracy, unraveling the appeal of alternative truths. The Flat Earth theory persists not because of scientific evidence, but despite it. It thrives on distrust of authority, often manifesting as a rejection of government institutions and scientific consensus. The internet has provided a platform for these ideas to flourish, connecting like-minded individuals and creating echo chambers where alternative facts reign supreme. Why are these theories so alluring? For some, it's the appeal of feeling like they possess secret knowledge, of being privy to truths hidden from the masses. For others, it's a way to make sense of a complex world, to find comfort in simplistic explanations. But whatever the reason, Embracing such beliefs comes at a cost: the erosion of trust in legitimate sources of information and the rejection of critical thinking. Section 7. Science under siege: the threat of misinformation and the value of critical thinking. The persistence of the flat Earth theory, despite overwhelming evidence to the contrary, highlights a concerning trend: the increasing acceptance of misinformation and the erosion of trust in scientific expertise. In our information-saturated world, it's easier than ever to encounter alternative facts, conspiracy theories, and outright falsehoods masquerading as truth. This is not just an academic concern. The rejection of scientific evidence has real-world consequences. Climate change denial, for example, hinders efforts to address a pressing global issue. Vaccine hesitancy, fueled by misinformation, threatens public health. When we dismiss scientific understanding, we do so at our peril. Section 8. Embracing the sphere, a final word on our round world. The Earth is not flat, it's a sphere, a celestial oasis hurtling through the vastness of space. While the flat Earth theory might seem like a harmless curiosity, it represents a broader challenge: the allure of misinformation and the importance of critical thinking. We must approach information, especially in the digital age, with a healthy dose of skepticism. Question your assumptions, seek out reliable sources, and embrace the scientific method, a process of observation, experimentation, and evidence-based conclusions. Our understanding of the universe has come a long way from the days of flat Earth myths. Let's honor that legacy by embracing curiosity, valuing knowledge, and never stopping questioning the world around us.